Here we're going to do the last step, or the more difficult looking linear equations. In this particular example, it's a little bit scarier because of the parentheses. Now, we'd want to do any cleaning up of an equation that we could first, and that goes back to our order of operations. But inside the parentheses, we cannot do x plus 4 because we don't know what x is. X is an unknown, so we can't add 4 to it, because if x was a 1, we get 1 plus 4, we'd have 5, but if x was 72, 72 plus 4 is 76, we get two different answers. So we cannot just add that, and don't start turning it into multiplication. Remember, 4x means 4 times x. Adding 4 is not the same thing as multiplying by 4, so be careful there. But we still want to get rid of those parentheses. And the step that we do in order to get rid of those is called the distributive property, because the second reason that these parentheses are there is to indicate multiplication. That's what the 3 is doing in front. The 3 is being multiplied to this quantity. That means that the 3 is being multiplied to every term inside the parentheses. So take your 3 and distribute it inside first by taking 3 times the x and 3 times the positive 4 for the two terms. Now the 2x out in front has nothing to do with that, so we just bring that along for the ride. But now we have plus 3 times x would be a positive 3x. And 3 times 4, well, we still need to separate the terms, so we need the plus sign to separate terms. And that's going to be equal to the negative 3. Now, after we get rid of the parentheses, we may notice that we have some like terms. If we have like terms on the same side of the equal sign, we just add them the way they are. If we have like terms on opposite sides of the equal sign, to get them together, we have to do the opposite or the inverse operation. The inverse of addition is subtraction. The inverse of subtraction is addition. Similarly with multiplication and division, they are inverses of each other. Now in this particular problem, we just have some like terms that are being gathered. On the left side, we have a 2x plus a 3x, so that would give us 5x. We're not moving it across an equal sign, so the sign does not change. So we have 5x plus 12 is equal to negative 3. And now, just like that, we're in our two-step problem that we did in the beginning. We have 3 terms. 2 of them are like. We want to get them on the same side of the equal sign, away from the term that's not like it. It's a positive 12, so we need to subtract 12. What you do to one side, you do the same thing to the other side. The 5x comes down for the ride. Those cancel out. Make sure that it does. Sometimes we miss our signs and we do the same sign. Double check. 12 minus 12. Yep, that's 0. On this side, it's a negative 3 and a negative 12. Same sign, so add the numbers and keep the sign. Add the numbers and keep the sign. Now we need to get the x by itself by getting rid of the multiplication. They're not like. Numbers and letters aren't like after all, so we want to divide and conquer. So to cancel this multiplication, divide it by 5. If I do that on one side, I have to do the exact same thing on the other side to keep it balanced. And we get x is equal to negative 3. Once again, you can always check all of your answers by plugging it back into the original for all of your x's. Simplify using the correct order of operations. Please excuse my dear Aunt Sally, also known as PEMDAS. But our solution has the variable attached. It's x equals negative 3. That one wasn't so bad. Let's do another. Ooh, I have a good one here. I think we'll like this one. 2 minus 5 times the quantity of x plus 5 will equal 3 times the quantity of x minus 2 minus 1. Now, lots of steps to talk about in this one. First of all, I see parentheses, and we don't want any of those. But before I even go into that, I want to make note of what happens out in front. 2 minus 5. A lot of us would think, hey, I can do that and come up with a negative 3. That's a big boo-boo, because remember, what's happening to the 5? There's parentheses after it, which indicates multiplication. According to our order of operations, we have to do multiplication before we do subtraction. If you didn't do the multiplication, you can't do the subtraction. So we cannot take the 2 minus 5. The second thing to look at on this problem is the sign in front of the 5. That same 5 we were talking about. We're subtracting. We need to remember that all subtraction is the same thing as adding a negative. So when we do our distributing here, we're not distributing through a 5, we're distributing through a negative 5. All subtraction is the same thing as adding negative numbers. So if there's a subtraction sign in front of a number, it really means that that number is negative, and the negative has to go with, because the sign in front of the term goes with the term. With that being said, I can now use my distributive law to get rid of my parentheses. Take the negative 5 that's on the outside and distribute it or multiply it to every term inside the parentheses. We're going to do the same thing on the other side over here. It's 3 times the x and 3 times the negative 2. Notice I'm not taking the 3 times the negative 1. That's outside the parentheses. It's not what the part that's being multiplied. So when we do that, the 2 out front comes along for the ride. Nothing that we're doing there. Negative 5 times x is a negative 5x. We write that as minus 5x. It's either a negative or it's a subtraction, not both. Negative 5 times a positive 5 is a negative 25 equals 3 times x is 3x. 3 times a negative 2 is a negative 6. There's still a different term, so you need to have a sign to cancel out, or to separate my terms, to separate your terms. And then don't forget that minus 1 at the end. Your next step is to clean up your like terms on either side of the equal sign. On the left side, we have like terms. What are they? Yes, the like terms are the 2 and the negative, the negative 25. So I'm taking 2 and I'm subtracting 25 from it. Negative 5x, we like to keep the terms with the variables by itself. 2 minus 25 is negative 23. Excuse me, I should clarify that. We like to keep the term with the variable first. Doesn't have to be, but we like to do that. Is equal to, and on the right side I have like terms as well. The 3x is not part of it. It's a negative 6 and a negative 1. Remember, the sign in front goes with. So a negative 6 plus a negative 1, if you change everything to adding negatives, it might be easier to see. I have a negative 6 and I'm adding a negative 1. Two of the same sign, we add the numbers and keep the sign. So that's going to make a negative 7. Now we have a problem in which we have terms with the variables on both sides of the equal sign, and we have constants, numbers that don't have the variables, on either side of the equal sign. I think your book and several others like to move the terms without the variables first. I don't like that so much. And the reason why I don't care for that is because then you can't make sure that the sign in your variable term is positive. As we stated before, I always like to make sure that the number in front of my x stays positive if I can at all control that. So I'm going to move those first so I can control it. Once again, in this case, I'm not going to be moving the 3x to the left side because negative 5 is further from 0 or a smaller number than a positive 3. We always want to move the smaller term to the larger term because when we switch the signs, it becomes a larger number. So to cancel out negative 5x, I'm going to add 5x. Negative and a positive get 0. Whenever we move terms, the entire quantities that are being added or subtracted, we do the opposite sign. Whatever I do to one side, I do the same thing to the other side. Don't forget the sign in front of the term goes with the term, so this 23 is still a negative 23. And now I have an 8x minus 7. My next step is to get the constants, or the terms that do not have variables, next to each other. I want to get them on the opposite side of the term that has the variable. So once again, I want to move the constant from the right to the left. It's a negative 7, so I want the opposite of that, which is a positive 7. Whatever I do to one side, I do the same thing to the other side. Now on the left side I have a negative 23 and a positive 7. One of each sign, we subtract the numbers and keep the sign of the larger, or the number that's further from 0. 23 is the larger number in the fact that it's further from 0. And it's negative, so my answer will be negative. Then 23 minus 7 is going to give us 16. And finally, to get our variable by itself, we need to cancel out this multiplication. To do that, we once again divide by that number in front. X is equal to a negative divided by a positive. One of each sign is a bad thing, so the answer is negative. So let's summarize the steps that we're going to do whenever we are solving linear equations. The first step that we want to do is to remove parentheses. Let's make sure our paper's on here, huh? To solve linear equations, the first thing we always do is remove parentheses. And we do that by using the distributive property. That's what we did when we multiplied inside. The second step we do is to collect or combine like terms. After we use the distributive property, we might have like terms like we did in that last example that we have to combine. We want to simplify things next, so that's our second step, is to combine or collect, your book calls it, I think, like terms on both sides of your equal sign. It's really important that you understand what terms and what like terms are. So combine or collect like terms on either side of the equal sign. Remember that this will be adding or subtracting, whatever the sign says. If we're not moving from one side of the equal sign to the other side, we keep the sign of the term. For example, in that last problem, we were adding our like terms here. It was 2 minus 25. We didn't switch the signs and add because we're on the same side of the equal sign. So we simply took 2 minus 25 to get our negative 23. Similarly, on the other side, the negative 6 and the negative 1, we kept the signs and simplified them as they were. So that's the second step. Your third step is to move all variable terms to one side of the equal sign. Move the variable terms. Those are the terms with the variables. And we do that by using inverse operations. Once again, the inverse of addition is subtraction. The inverse of subtraction is addition. Whenever you move a term, you're adding or subtracting. Step 4, when solving linear equations, would then be to move your constant terms to the other side. Those are the terms that don't have the letter. And once again, that's inverse operations. We always did that in that purple color. And once again, since we're moving a term, we're adding or subtracting. And then your last step is to get the variable by itself. That last step would have maybe a number in front of the variable. And remember, that means multiplication. So the last step is going to be to divide both sides by the coefficient of the variable. Coefficient is a big word. It simply means the number in front of the variable. And yes, for the purposes that we're doing, we're going to be dividing. Technically, you could be multiplying if there is division there, but we're not really going to be doing a whole lot of those types of problems. Right? So those are the 5 steps for solving linear equations. Remove the parentheses using the distributive property. Combine or collect your like terms on either side. This is when we keep the signs the same as what's there, and we're just gathering them together and simplifying. Move your variable term to one side of the equal sign. We'll add or subtract to do that. Move the constant term to the other side of the equal sign by adding or subtracting as well. And then divide both sides by the coefficient, or that number in front of the variable. Those are your steps to solving a linear equation. Remember, you can always check your answer to know if you got it right for sure.